So hello everyone, let us solve another LeetCode problem, and the problem name is Bitwise OR of Subarrays. So let us read the problem statement first. So given an integer array ARR, we need to return the number of distinct bitwise ORs of all the non-empty subarrays of ARR array. Now then they have given the definition of what is bitwise OR and what is a subarray. So this problem is very easy to understand because it simply means that we need to take bitwise ORs of all the subarrays, and whatever total distinct bitwise OR values that we get, we need to return the count. So this is very easy to understand problem, and trust me, this is very easy in terms of solving as well. So how will we solve this problem? Now this question is not about just the solution, it's also about understanding the time complexity, because in this question the main understanding is of the time complexity. So first of all, let us find the solution, then we will understand the time complexity as well for this particular problem. So let us take this third example and try to understand how will we solve this problem, and then we will understand the time complexity. So this is the given array ARR. So let me just write down here, and the first thought, how will we solve this question? By taking all the subarrays, taking bitwise OR would be a naive approach, and it would be something big of n cube. You can just try it out. I'm not going to explain the brute force approach, but yeah, this is the brute force approach, which will take big O of n cube, where you will take all the where you will check all the subarrays, then take bitwise OR of that and store it in some answer, and then return the length of that answer. This was the brute force. Now what will be the optimized solution for this? The optimized before the optimized solution, let us try to just like simulate the entire process, how this entire subarray, how will we take the bitwise ORs and all of these things. Let us simulate the process. So if we are at this current value, how many subarrays are possible? There can be only one possible subarray, and that will be the number itself. So what will be the bitwise OR value? This number itself. Then we come on to this second value. This second value is what? 2. Now how many subarrays can be formed? Obviously the number itself, and it can also form the subarray with the previous number, that is 1, 2. So 1, 2. Then we will come on to the next number. Next number is what? 4. Next number is 4. Okay, so how many subarrays can be possible? The 4 itself and subarrays with the previous number. So it can make subarray with 2, 4, and it can make subarray with 1, 2, 4. 1, 2, 4. Now what we need to do? We need to take the bitwise OR of all the subarrays and return the total unique bitwise OR values. Now how will we do it? Instead of checking the subarrays, like here we are storing the subarray, right? Can't we just store the bitwise OR values? Yes, try to just do this particular thing with the bitwise OR values. Okay, so this was the array 1, 2, 4. What was the first bitwise OR value? It was 1, because there was only one number in the subarray, so its bitwise OR value will be the number itself. What can be the bitwise values for when we are at this particular index? The number itself and with the previous subarray. So it was 1 or 2. Now when we come at this particular 4, what can be the bitwise values? Obviously the number itself and with the previous values. So once it will do OR with 2, so 2 or 4, and then it will do with 1 or 2 or 4. So these will be the bitwise OR values, and among them we will take only the unique ones. I am not calculating the unique ones, but yeah, this is the logic. So it feels very simple, right? We just need to check how many previous values are there, and for the current value just OR it with the previous ones, right? Yes, this is the actual solution for this as well. But you might say that this is also not the efficient solution, because the constraints are given as something like this, like 5 cross 10 raised to the power 4. So you are right, okay, one outer loop will be there for going to each and every index, and this array can be of length at max n. So our outer loop will be running n number of times, right? And for taking the bitwise OR with the previous values that we have, that can also might go up to n length as well, right? So it will go n cross n, so it will be big O of n square, right? Because the inner loop will also have need to be run on the previous bitwise OR values, so it might go up to n square as well, right? No, it is not right. Why? Because you are missing out one very important thing in this question, is that bitwise OR. Now if you have solved some bitwise OR questions or bit manipulation questions, you might have studied the properties of those bitwise operations as well. Now let me tell you very interesting thing about this bitwise OR. This bitwise OR has a very unique property that whatever number you have, if you OR it with some other value, that number that we get in our answer will either be same or it will increase. It will never ever decrease again. So what does that mean? So if we have like 32 bits in our total integer, like the number range, so if we have one bit set, it can never unset again. It can only set or remain set. It can never be again 0 again. So how many total unique possible OR values will be there? If we have 32 bits in our number system, then our bitwise OR values will also be at most 32 only. So you are right to say when you say that your external loop will run n times, but you are wrong when you say that our internal loop will also run n times. No, it will only run 32 times, because at most 32 times, not every time, at most 32 times, because we will have only 32 bits to set, and if a bit is set, it will never unset again. So we can at most set 32 bits. So if we can set at most 32 bits, we can have at most 32 unique values. And if we have 32 unique values, our inner loop will run big O of 32 times. And that gives our time complexity overall to be big O of n cross 32. So it is not big O of n square. It is actually big O of n cross 32. So the question was very simple to understand, but the main part to understand this question was in terms of the time complexity, and this is how the time complexity comes. So the solution is very easy. Just take the previous OR value, previous OR values, just OR it with the current value, and just store the result, and in the end just return the size of the result. It is very simple, but the main part was to understand the time complexity. So I hope you understand the solution as well as the time complexity part. So let us directly jump onto the code, because there is nothing much to discuss in the algorithm part, because it is very straightforward. I hope you understand this part as well. So let us see the directly code now. So this is the code. So first of all, I am taking unordered set previous, which will store the previous bitwise counts. Then I have the current, which will be storing the new result, or it will storing the new values of bitwise OR after ORing the current number with the previous values. Then I have declared another unordered set called answer, which will be storing all the unique bitwise OR values. So first of all, our external loop, where which denotes if we are standing at I, how many possible sub arrays are there, or how many possible bitwise values that we have till now. It denotes that part. The second part, whatever bitwise values we have previously, just iterate on that and OR it with the current value. After ORing it with the current value, also store it in our answer, because in the end we just need to return the answer dot size. And before clearing this current, store our new current with the previous, because now our previous will be the current value, and this previous will now move on further. In the end, we are just returning the answer dot size, because whatever total unique bitwise OR values that we have, we just need to return the count. So we are just returning its size. So this was the code part as well. It is very simple. The thing that we have discussed in the explanation part, just take the previous values, iterate on them, and just OR it with the current value and store it. And before moving on, just update your previous to be the current one, which will be storing the current bitwise or values till now. So this was the code. I hope you understand the entire explanation and the question. So thanks for watching.